Hi everyone, welcome to the Earth Science Regents Review podcast series created by Hammock's Middle School Earth Science Department. Today we're going to talk a little bit about chemical weathering. Now in order to understand weathering, you have to have an idea about the difference between weathering and erosion. Weathering is the actual breakup of rock into smaller pieces called fragments or sediments. Sometimes there can also be a chemical change as well to the composition of the rock. Now sometimes those sediments get transported to a location. That's what we call erosion. And that can be done by wind, water, gravity, or glaciers. Today we're going to simply focus on the chemical change within the rock. We'll talk about some of the features that are created through chemical weathering. Now, like I stated earlier, there are two types of weathering. You have the physical or mechanical, and I already have a podcast created for that one. Today we're going to focus on the chemical aspect of weathering today. Now with chemical weathering, like I stated earlier, there's a change in the composition to the rock, and there's three ways in which this can happen: oxidation, carbonation, or hydration. A good place to check this out is in a graveyard. If you look at the headstones, very easy to tell what rock is resistant to weathering and what rock is going to be really less resistant to weathering based upon the clarity of the letters and numbers on the headstone. If the letters and numbers are really wiped out, you probably have a pretty soft rock. If you're still very legible and you can really read them nicely, you probably have a really resistant rock. So the name of the type of weathering that we're going to talk about actually gives you a clue about what attacks the rock itself. So in oxidation, oxygen combines with the minerals and elements within the rock and produces a red rust color to the rock, a beautiful, beautiful red color. And the reason is because of the iron within the rock. The iron and the oxygen really attack each other, and it ends up being a very red, rusty color, much like the red rock in Sedona. Next type is what we call carbonation, and this is where carbon dioxide combines with the minerals and elements in a rock and attacks it. Specifically, there's a mineral calcite that gets attacked. What happens here is that you tend to get carbonic acid. The carbon dioxide dissolves into water and creates a very weak acid called carbonic acid that attacks the calcite in limestone or marble. Well, if you're given enough time, that rock gets eaten away and it creates features underground called caves or sinkholes. So here's kind of what a cave system might look like. And here's what a sinkhole looks like. And really what happens here is that the rock just can't support the overlying soil layer, and the soil just gets too heavy and caves in upon itself. Now, there are some features in a cave you should have an idea about. A lot of times caves are under the water table, so some of that water will drip through the joint system in the ceiling. If that water is loaded up with enough calcite, that water will evaporate off the ceiling and create a structure called a stalactite over millions of years. If that drip is big enough and it falls to the surface and falls to the floor, what will happen here is that now that structure is going to be growing up from the ground. That's called a stalagmite. And if they meet up with each other, they're called a column. So this picture shows all those features. Now the last type is what we call hydration. And this is when water is going to attack the minerals and elements within a rock. And really what happens here is that it turns very hard minerals into very soft substances. And a good example of this would be feldspar, would be attacked by water in the hydration process to create a very weak clay. And that's what's demonstrated here on the right-hand side of this region's diagram. So those are your basic types of chemical weathering that you should have an idea about. Now realize that chemical weathering only happens in certain parts of the country, more prominent than others. So climate's going to have a major impact in terms of the types of chemical weathering that you're dealing with. So basically, the majority of our chemical weathering is going to be found in the tropics, very simply because of the hot temperatures and lots of moisture. So you'll see a similarity between chemical and physical weathering in terms of you need a lot of water, but for chemical weathering, you need the hot temperatures as well. So with that being said, that's it for now in terms of our chemical weathering, and we'll talk to you soon.